Let's try another examples of integrations by parts. There will be two functions here in the relationship of the products. With that, you know that you're going to solve it by using the formulas of the integrations by parts. There will be boundaries for the integrations. That means this involves the definite integral. With that, let us set u equals to 2 theta and the remaining will be the dv. Differentiate the u, you get du equals to 2 d theta. From the dv here, integrate it, you obtain v, which is equals to negative cos theta. Adopt the formulas of integrations by parts. U, v, v, du. Integrate this, you get 2 sine theta. There will be a c at the end of the expressions. Rearrange these two terms. You will get the solutions for the integrations of the function. Next, you need to solve the integrations with the integral limits. Bring the upper and lower boundary here. Substitute the upper boundary to be minus with the lower boundary. Solve the equations, you get the answer. Let us try another example. There are two functions here. That means you're going to use the formulas of integrations by parts. There are boundary. That means it is a definite integral. Let u equals to 5x. The remaining will be the dv. Differentiate the u. You get du equals to 5 dx. Integrate the dv, you get this. Adopt the formulas for integrations by parts. U, v, v, du. Integrate the v du. Remember to put in the c at the end of the expressions. Rearrange the equation, you get this. Define the limits. Substitute the upper limit to be minus with the lower limits. Solve the equations, you get 51.5. Let us try another example. There are two functions here. That means you have to do integrations by parts. Let u equals to x squared. The remaining will be the dv. Differentiate u, you get du. Integrate dv, you get v. Use the formula u, v, integrations of v, du. Integrate the v du, you will get this. However, the integration here again constitutes of two functions. You will have to do the integrations by parts again at the second level. Let u equals to 2x. The remaining will be the dv. Differentiate u, you get this. Integrate dv, you get v. Use the formulas of integrations by parts. U, v, v, du. Remember to put the c. The integrations of these functions, you will get this. Substitute the solutions here. Rearrange it, you get the final answer. Let us try another example. In this case, it is x ln x dx. Normally, we use the first term as a u. In this case, we use ln x as the u. The reason is there is a formula for us to differentiate ln x, but we do not have the formulas to integrate ln x. With that, we will set u equals to ln x. Differentiate ln x, you get 1 per x dx. The remaining will be dv. Integrate dv, you get v. Use the formulas of integrations by parts. U, v, v, du. Solve the function here. You will get this. Integrations of this, you will get this. Remember to put in a c. Rearrange the equations, you get the final answer. Let us try this example. In this case, you have only one term, but it appears in ln x. Refers to the tables for the standard integrations. We do not have the formulas for ln x. With that, we can try to solve this by using integrations by parts. Ln x itself will be equals to 1 times ln x. So, let u equals to ln x. The remaining will be the dv. Differentiate ln x, you will get 1 per x. Integrate dv, you will get v, which is equals to x. Use the equations of integrations by parts. U, v, v, du. Simplify the function here. You will get equals to 1. Integrate 1, you will get x. Remember to add in the c here. This will be your final answer. Let us try one more example for the integrations by parts. There are two functions here, square root x and ln x. You know that it is related to integrations by parts. There are boundaries here. That means it is a definite integral. From the tables of formulas, there is no formula for integrations of ln x. With that, you will choose the u as the ln x. The remaining will be the dv. The dv of square root x dx can be rewritten in the power of 1 per 2 dx. Differentiate ln x, you will get 1 per x. Integrate this, you will get v. Use the formulas of the integrations by parts. U, v, v, du. Simplify the function here. You will get this and you integrate it. Remember to put in a c. Rearrange and simplify the equations. Now you define the boundaries. Substitute the first boundary into the functions to be minus with the substitutions of the second boundary into the functions, and the final answer will be equals to 28.